Hi, welcome back. In this lesson, I am going to discuss about reference types in detail. By the end of this lesson, you will be able to understand how the memory is allocated for the primitive types and how it is allocated for the reference types. Once you are able to understand this one, you will be able to understand what is the difference between primitive type and reference type. Also, you will be able to explain why we call them primitive type and reference type. After that, we are going to explain and we are going to see the differences between reference variable and the object. Because some people are going to have confusion about reference variable and object, I am going to explain that particular concept in detail. Also, by the end of the lesson, you will be able to refer to the same object using different reference variables. In this lesson, I am going to explain all those concepts using the same class that we have created in previous lessons, that is myDate class. It is having some fields, some constructors, some member methods and getters and setters. Let me show you the same thing in the IDE. The picture is easy to recollect, but nonetheless I am going to show the same thing in the IDE because that is where we have coded all these things. So here we created a class called myDate and it is having the 5 fields. And then it has some methods. Also we have created constructors, getters and setters, the toString method using the IDE shortcuts. Okay, then in the main method we created a couple of objects, then we have printed them. So we know how to code these things, but when the program is getting executed, we need to understand what is happening in the backend, or what is happening actually, how the memory is allocated for these variables, when the memory is allocated, where the memory is allocated, how the variable or how the reference type variable is able to refer to this particular object. So all those things we are going to see now. Okay, I am going to explain everything on the timeline. So when the program gets executed, what happens? When we enter the main method, what happens? Okay, by the moment we enter the main method, 3 things are going to happen in this particular case. Okay, so the first thing is, in the main method we are creating multiple objects of type myDate. So in order to create those objects, we need to understand, or the program needs the class definition. So as a first thing, the class will be loaded into memory. Without loading the class, we can't create the objects, because the objects are nothing but instances of this particular class. So the class will be loaded. Apart from that, there will be 2 memories that are allocated. One is called stack memory and another is called heap memory. We are going to see when we use the stack memory and when we use the heap memory. Okay, but before creating our objects, let's create one primitive type variable first. So here I am creating a primitive type variable that is integer. The variable name is I and I am assigning a value of 10. So where is this variable created? Where is the memory allocated? The memory is allocated on the stack. Okay, here you can see that on the stack memory, a memory is allocated and the memory is referred using the variable name I. So at this particular memory, the value of 10 will be stored. The end of story. So you have created a variable, you have assigned some value for that particular variable on the stack, memory is allocated. Inside that memory, the value is stored. So the memory allocated is enough to save that particular integer. Okay, that is all about primitive types. But now let's create an object. Let's create an object of type myDate. So how do we create? Okay, we create myDate1 equal to new myDate2. So here we are invoking the constructor using the keyword new. So as a result, new object is created. But where is that particular object created? This object is created on the heap memory. Okay, so when the object is created, the memory will be allocated and the memory is for all the variables that this particular object has. So in this case, the object has year, month, day, era and day of week. So for all these data, there will be memory allocated and they all will be part of this particular object. Let's say this object is created at address 100. Okay, object is there that is created as a part of the constructor invocation using the keyword new. Okay, so but we also created a variable name is myDate1 and it is of type myDate. When the object is created, it is going to return a reference. So reference is nothing but the address. Okay, because the object is created at address 100, that particular address 100 will be saved in this particular variable. So here you can clearly see that there is a memory allocated for this reference variable on stack, but the value assigned to this particular variable is not some value, it's nothing but address. Using this address, the variable will be able to access the object, or it will be able to refer to this object. Okay, let's see the same thing for a different object. Okay, we created one more object using the new keyword. Also, we created one more variable, and at the end we assigned this particular object to this particular variable. A variable name is mydate2. So here, because we created one more object, the object will be created on the heap. Let's say the object is created at address 200. Also, this object is going to have enough memory for all these variables. At the end of this expression, the address 200 will be saved in the variable mydate2, and using that address, the variable will be able to refer to this particular object. Okay, that is what is going to happen when you create a variable of reference type and then you are going to assign an object to that. Okay, now what I'm going to do is I'm going to create one more reference variable. The reference variable name is mydate3, but now I'm not creating a new object. Instead of creating a new object, I'm simply assigning existing variable. Existing variable name is mydate2. So basically I assigned mydate2 to mydate3. Okay, what is there in mydate2? If you see here, inside mydate2 we have address 200. So this address 200 will be assigned to mydate3 also. So that is what happens as a result of this particular expression, mydate3 equal to mydate2. Whatever is there inside mydate2 will be copied to mydate3. Okay, so now this variable mydate3 is having address 200, and using that address 200, it will be able to refer to this particular object at address 200. So if you see here, both variables mydate2 and mydate3 are referring to the same object. So on the left hand side, you can see the code and you can clearly say that we have defined three variables, that is mydate1, mydate2, mydate3, but we have created only two objects here using the new mydate, passing the values 2012 11, and here using the new mydate using the values 2017 January 1st. So we created three variables, we have only created two objects, but by the end of this expression, first variable is referring to the first object, and second and third variables, they are referring to the second object. That is all about this lesson. At the end of this lesson, we are able to clearly see that on the stack memory we are going to have some variables, but on the heap memory we are going to have the objects. Whenever memory is allocated for this object, the memory allocated is sufficient to hold all the values or all the fields that are contained inside this object. So if you need to understand the memory required for this object, that will be decided by all the fields, all the values that are stored inside this object. Okay, so now we are able to see the difference between primitive type and reference type. In case of primitive types, the memory allocated for this variable will be having the value, whatever value we assign. But in case of reference types, the variable will hold an address. Using that address, it refers to an object. So for this particular variable, you can't assign any value, something like you can't assign a value of 100. So here on the left side, if I write mydate1 equal to 100, it won't compile, because you can never assign some value to this variable. You have to always assign some object to this particular variable because it is of type reference type. Okay, you can also assign null, that we are going to see in the next lesson, but always remember reference type variables has to refer to some object. They can't have some value. They are always going to save address and refer to a particular object. Okay, that is the main difference between primitive type and reference type. That is also the reason why they called primitive types and reference types. Also, we are able to understand all the objects will be created on heap memory. Okay, that is the end of this lesson, but I want you to practice. I want you to write this statement, write these expressions, then I want you to draw this particular diagram. Unless you are able to draw this diagram, you are not going to be able to understand any other programs. So this is the basic concept between objects, reference types, and all those things. Unless you understand this one, as I said, you you can't proceed further. So make sure you take pen and paper, write this code, create these diagrams, and know where the heap memory is, and where the objects are created, where the reference variables are created. Okay, in the next lesson we are going to see one more important concept. So here, using the constructor, we created objects. So if we have created objects, we have to destroy them. Why do we need to destroy it? So the amount of memory available for a program is limited. So if we go on creating objects, and if we don't remove those objects, or if we don't destroy those objects, then there won't be sufficient memory after some time, because whatever objects we created so far, they're going to take all the memory, and there won't be enough memory for the new objects. So in order to give space for new objects, whenever we are done with a particular object, we want to get rid of it, we want to destroy it. So we are going to see how to destroy it, who destroys that particular object, when they destroy that particular object, what are the things that we need to do in order to make sure the objects will be destroyed whenever they are no longer required. Okay, all those things we are going to see in the next lesson, but for now, please practice this one, and once you are able to draw this particular diagram, continue with the next lesson. Once again, welcome back to Manohar Academy. If you did not subscribe already, please go ahead and subscribe. Also, if you like this video, if you are benefited from this video, please like it, share it with your friends so that they can also watch and learn. Once again, welcome back. See you in the next lesson. Thank you.